Welcome everyone. Today, in this session, I will give an introduction to complex analysis. So, in this word complex analysis, first we shall come across the word analysis. So, analysis, or can call it as mathematical analysis. Mathematical analysis. So, knowingly or unknowingly, we are studying this mathematical analysis since PUC. So, if we define this definition, we will come to know about that. Mathematical analysis is a branch of mathematics, which deals with the study of limits and related theories such as differentiation, integration, measure theory, infinite series concept, and ultimately analytic functions. So, analysis or mathematical analysis is a branch of mathematics which deals with the study of limits, concept of limits, and its related theories. Theories based on the limits such as differentiation, integration, measure, infinite series, and analytic functions. Right? So, in this definition, you know what you mean by limits. So, limit is that mathematical concept which give rise to many sub-branches of mathematics. So, limit concept means basically it is based on a function. So, if we have a function y which is f of x, function of x, as x approaches to a, what is the value of f of x? What is the value of f of x? So this concept is called limit. You have all study about the limit concept. So if you have a function y is equal to f of x, so you can draw it geometrically on a plane by marking x values along the x-axis and function values along the y-axis. So for if I have the function y to be x square, suppose if I have the function y is equal to x square, for the x values 0, 1, x equal to minus 1, x equal to 2, x equal to minus 2. So for these domain values, for these x values, the function y is equal to x square takes. So this is the x equal to 0 value. So if I put x equal to 0, 0 square is 0, so y is 0. So at x equal to 0, y is also 0. So this is the first point. Then take x equal to 1. So if I put x equal to 1, 1 square is 1. So at x equal to 1, y also takes plus 1. So this is the point. Similarly, if I take x equal to minus 1 whole square is again plus 1. So at minus 1 also y takes plus 1. So this is the point. Then if I take x equal to 2 square is 4. So at x equal to 2, y takes 4 value. This is 1, this is 2, this is 3, this is 4. So at x equal to 2, y is 4. Similarly, put x equal to minus 2 whole square is 4, y is again plus 4. So at x equal to minus 2, y is again 4. So like this, you can plot many points and joining these points, you will get a curve. You will get a curve on the plane, and this is nothing but the function y is equal to x square. So limit concept means, so as x approaches to some value, say, so as x approaches to 0, so for what value y will approach. So this is called the limit concept. And based on this limit concept, many mathematical concepts are discussed. Right? So on this limit concept only we discuss differentiation. You know what do you mean by differentiation? So differentiation means what is the change in function value or slight change in the domain value x. So differentiation means, so again I'll start with a function y is equal to f of x. Means y represents some function of the variable x. So suppose if I draw that function on the plane, assume that its curve is like this. As I draw before I draw y is equal to x square, like that. If I draw f of x, assume that its curve is like this. So now I will mark 2 points x1 and x2. So for the point x1, the function value is f of x1. The corresponding value of function is f of x1. Like that, for x2, the corresponding value is f of x2. So this difference, this is the change between two corresponding points of the domain of this function. Corresponding to this change, so what is the change I have got in the function value? Say, if I take f of x1 as the value y1, so it is here, and for f of x2 is the function value corresponding to the domain point x2. So if I take it as y2, so this is y2. So x2 minus x1. So x2 is the larger value. So x2 minus x1 will give you the difference between these two domain points. So corresponding to this change in domain value, so what is the change in the function value? This. So at x1, function value is f of x1. At x2, function value is f of x2. So the change is this one. That is y2 minus y1. y2 minus y1. So for this corresponding change, so now I put a change in. So first x1 into, then I gave the value x2. So the change is x2 minus x1. Corresponding to this change in the domain value, I got the change y2 minus y1 in the function value. Right? Like that. So if I get a small change in x value, so it is denoted by delta x. Delta x is the small change which I have given to the domain value. Corresponding to that change, assume that the function change is delta y. This is the change I have obtained in the function value. So if I take the limit as delta x approaches to 0, then I get dy by dx. That is differentiation of y with respect to x. So for any function y is equal to f of x, dy by dx, differentiation of y with respect to x is nothing but limit delta y by delta x as delta x approaches 0. So this means for a smaller change, delta x and change. So for the change which I am giving to the domain value. So for smaller change, as delta x approaches 0 means for a negligible change in x value, what is the change in y value? ಸ್ವಲ್ಪ x ಅಲ್ಲಿ ಸ್ವಲ್ಪ ಚೇಂಜ್ ಮಾಡಿದ್ರೆ y ಅಲ್ಲಿ ಏನು ಚೇಂಜ್ ಅಪಿಯರ್ ಆಗುತ್ತೆ. ಸೊ ಆ ವ್ಯಾಲ್ಯೂ ಅನ್ನು ನಾವು dy by dx ಅಂತ ಕರೀತೇವೆ. So to define differentiation of a function, we need purely the concept of limit. And you know that integration is the inverse of differentiation. So like this, analysis means it is the branch of mathematics which deals with limits and the related concepts to the limits. Limits ಮತ್ತೆ limits ಗೆ related ಆಗಿರೋ ಎಲ್ಲಾ theories ಅನ್ನು study ಮಾಡೋದೇ the branch called analysis. And under this mathematical analysis we have many sub branches. Now I will list those sub branches. Okay, so mathematical analysis means first of all it is study of limits and related theories. And the related theories, some of the related theories are differentiation, integration, measure theory, then sequences and series concept. That is infinite series, and we get a series by a sequence itself, and finally analytical functions. So study of these related theories to limits is called mathematical analysis. Now, to study these theories, we need some domain. That means, so for example, if you are given to talk or to give a speech, immediately you ask the topic. So on what topic I have to give the speech. Similarly, to study these theories, we need a domain. Or we can say context. On what context or on what basis we can study these theories. For example, differentiation integration. To study differentiation integration, we need functions. Functions is the domain. And to study infinite series and sequences, we need elements, numbers, elements, anything. So domain or context is nothing but the basis for these theories. And mainly the two domains on which we will study these theories are real numbers and complex numbers. These are the two main domains on which we will study these concepts or theories. So mathematical analysis is further divided into sub branches. They are, so first one is real analysis. The second one is complex analysis. Third one is functional analysis. Fourth one is differential equation. equations. Fifth one is real analysis, complex analysis, functional analysis, differential equations, measure theory, and finally numerical analysis. So these are the main sub branches of analysis. Apart from this, there are other sub branches also, but these are the main sub branches of mathematical analysis. In this, the first one is real analysis. So real analysis means it is study of these concepts based on the domain real ones. If you study the limits and related theories on the domain real numbers, then it is called real analysis. So if you use the domain real numbers, then we have to discuss differentiation and integration of only real valued functions, right? Because to study differentiation and integration, mainly we need functions. So our functions are real valued functions use then it is called real analysis. Similarly, if we study series and sequence of real numbers, then it comes under real analysis. So mainly, so if I want to give the definition for real analysis, it is a branch of mathematical analysis which deals with the study of theories of real numbers and real value functions. So, real analysis means it is a branch of mathematical analysis which deals with the study of theories related to real numbers and real value functions, which constituted by differentiation, integration, infinite series, infinite sequences. If you study differentiation, integration of real value functions and sequences and series of real numbers, then it is the branch real analysis. So which you have already studied in previous semesters, right? Then I come to differential equations. So first of all, differential equation means an equation which consists of derivatives. So differential equations is that branch of mathematical analysis which deals with the study of different types of differential equations. Right? So first of all, differential equation means equation consisting of derivatives. Just for example, say x square dy by dx plus say x d square by dx square equals 0. So it is an equation which consists of derivatives. So dy by dx, it is, I can say it is a first order derivative of y with respect to x, and we have another derivative d square by dx square. It is second order derivative of y with respect to x. Like this. So any equations containing derivatives are called differential equations. And study of such differential equations constitutes the sub-branch of mathematical analysis called differential equation. So based on the degree of derivatives, we come across many differential equations. First order differential equation, second order differential equation, third order like this. And in that derivatives also we have ordinary derivatives and partial derivatives. Right? So based on that also we will have ordinary differential equations and partial differential equations. Study of all these differential equations will constitute the branch differential equations. In that you have already studied ODE, that is ordinary differential equations. Then we come to this sub branch, which is the numerical analysis. So numerical analysis is also a sub branch of mathematical analysis. Mathematical analysis which deals with the study of methods which gives approximate values. Approximate values. So it is a branch which deals with the algorithms. You can say algorithms, or you can say methods also. It is study of algorithms or methods which give approximate values. Approximate values. So, for example, to solve a system of linear equations, we have many direct methods. Like for example, if I have 2x suppose if I have a system 2x plus 3y equals 6, 5x plus 4y equals 7. It is a system of linear equations in two variables. So to solve the system, solving the system means finding x and y values which will satisfy both the equations simultaneously. Right? Solving means finding the values for x and y which will satisfy both the equations. And to solve these equations, we have many methods. So analytical methods will constitute to making. We have three: elimination method, cancellation method, formula method. Right? Elimination method means we have to eliminate any one of the variable, and then we get the value of another variable. And substituting back the value of that variable, we get the value of another variable. So these are the three analytical methods. That is substitution method, elimination method, and finally we have one formula, which will be a formula method. So to solve this system of linear equations, we have these three analytical methods. Substitution method means, so for example, in the system, so I take this second equation and I write it in terms of y. 4y equals 7 minus 5x, or y equals 7 minus 5x by 4. So if I substitute this value of y in the first equation, right, in place of y, if I substitute 7 minus 5x by 4, then the first equation will get converted into equation in only one variable, that is x, and which can be solved by transposition. By transferring all to the right side, then I get the value of x. This is called a substitution method. Right? The second is elimination method. Elimination method means eliminating any one of the variables. And finally, formula method means we have a formula to solve the system. Using that formula, we can also solve the system. So these are the three analytical methods to solve a system of linear equations. Apart from this, we have matrix method also. Right? We have matrix method. And we have discussed that in the linear algebra. By expressing this system in the matrix form, we can also solve this system. Right? These are the direct methods. In the sense, these methods will give you the exact values. Now, if I come to numerical analysis, to solve the same system of linear equations, we will have some methods which will give you approximate values. So those methods will be Gauss elimination method, Gauss seidel method, We have discussed that in numerical analysis in the first semester. So those methods are for solving the same system to get approximate values. So yavella methods approximate values annu kodutho ayella methods numerical analysis alli barutade. So numerical analysis is that branch of mathematical analysis which constitutes algorithms or methods to get approximate values. So these methods will give you direct or exact values for the system. To solve the same system, we have some other methods which give you approximate values, approximate answers. Those methods will come under numerical analysis. So these are the three branches of mathematical analysis which we have already studied. We have already studied these three branches. Now, so functional analysis and measure theory. So measure theory will come in this semester and functional analysis will be in the next semester. So I will not talk about these two. Now, this center of attraction now in the session is complex analysis. So complex analysis is that branch of mathematical analysis which deals with the study of theories of complex numbers and complex value functions. So these two branches differ by only the domain. So if you study theories of limits and its related theories based on the real numbers, that is called real analysis. If you study the same theories based on the complex numbers, then it will constitute complex analysis. So if I want to define the complex analysis now, so I have this. So these are the 6 sub-branches of mathematical analysis. Among that, in this paper, we shall study about complex analysis. Complex analysis. In simple words, if I want to define complex analysis, it is just study of limits and its related theories based on the domain complex numbers. You know what are complex numbers? I will explain those in the next immediate session. So complex analysis means it is a branch of mathematical analysis. It is a branch of mathematical analysis which deals with the study of theories of complex numbers, and complex value functions. Theories of complex numbers and complex value functions. So all the theories related to complex numbers and complex value functions come to the complex analysis. Now, in the next session, I will explain about the complex